A big hole has been found in the moon. Inhabitable, maybe even mining. According to Natural Astronomy's July 15 Shield article, a huge cave has been observed on the moon. The entrance is in the offshore area, can be accessed directly from the surface. What's in this hole? What value can be provided to mankind? Study shows that this big hole is 45 meters wide, 80 meters long, 150 meters deep, entrance in the offshore region of the moon. It's got the deepest cave pit in the world. You can get in through the pit. Tomorrow, humans are trying to get in through here. No need for a submarine. Because offshore, although there is hemming, but not the sea. It's a plain on the moon. A sea like this, there's a lot on the moon. There's also Lake Bay, with a name like that. Not that there's really that much water on the moon. It's a long-standing misunderstanding. In the old days, people used telescopes to look at the Earth, finding it darker in places. It's bright in places. Consider the dark places, because of the ocean. Lower reflectivity than the rest. That's why there's the Jade Sea. Riddle, some dark areas are small, not counting the sea. That's how we got the names Moon Lake and Moon Bay. Counterpart, where it looks brighter, it's treated as land. Call it the Moon Road. One of the lunar seas is offshore, but it is inferred to have formed during the late marine asthenosphere, mainly composed of basalt. It's like basalt on Earth. The basalt on the moon is also made from magma that cooled as it gushed out of the ground. These basalt rocks are dark in color. It's full of holes. The stomata may be filled with other minerals. Compared to Earth's basalt, these basalts are high in titanium and iron. Can be used to refine titanium and titanium dioxide. Titanium can be refined to make titanium alloys. It's a new material, widely prohibited in aerospace and marine applications. Titanium dioxide is a white coating, generally known as Ti-Bi. Great utilization in the field of optical storage enzymes, cosmetics, etc. Not only that, but iron extracted from the bottom of the moon's basalt. Carbon can also be used to build a moon base. Extracted oxygen can react with hydrogen to produce water, to provide a source of life for future life on the moon. I'm done with the basalt. Follow this huge cavern into, there may be green peridot in there. The deep mineral olivine, rich in olivine and low calcite, which was previously detected by Lunar Rabbit 2 on its voyage to the moon, is also found on Earth. It's one of nature's oldest gems. Full body green. Being circulated among merchants as a costly treasure. Peridot on the moon has more iron than on Earth. In addition to operating the gemstone, perhaps of greater value is the refining of iron. These olives are more likely to be buried deep in the ground. Lunar magma evolutionary rocks of the day. The lighter plagioclase floats to the surface and forms the lunar crust. Sinking of materials such as olive limestone, formation of a monthly slough. So the moon's surface is full of lighter minerals. Down the line there might be more valuable minerals. In addition there may also be a lot of water ice here. Water ice is a substance that lies between ice and water. If mining is successful, will effectively solve the water problem of the moon base. This underground cave discovery, more than just finding a more desirable site for a moon base. It may also find a rich mining area and a foothold for space mining. Scientists find large crater on the moon and what's inside is still unknown. The moon's complex environment produces many valuable minerals right on the surface. Helium-3 is one of them. Helium-3 is also found on Earth. But the reserve is only about 500 kilograms. $6 million a kilo. But the moon's magnetic field is so much smaller than the Earth's. So that more solar winds send more Ti-San to the moon's surface. Helium-3 freedom basically realized. Helium-3 is a relatively clean, efficient and controllable fusion material, and with a special superflow, characteristics such as nature, stability, non-radiation. It has broad application prospects in the field of controlled nuclear fusion, as well as nuclear magnetic resonance, ultra-low temperature refrigeration, nuclear explosion detection, etc. These substances on the surface of the visible light are enough to benefit many people. Not to mention the undiscovered lunar depths and the surface. Mining is an engineering project of the first magnitude. It's just that bigger returns mean bigger risks. The moon weighs only 1/6 as much as the Earth, daytime temperatures as high as 127 degrees Celsius. It plummets to -250 degrees Celsius at night. Such an extreme environment combined with a vacuum several times higher than that of the Earth. It gives the moon's soil a special mechanism. Mining on the moon isn't as easy as digging on Earth. The construction and materials of mining machines have to meet very high requirements. In addition the moon also has small, closed moon sinks. Easily adsorbed into the float. Drill into the astronaut's respiratory system. Impair. Additionally, the moon's surface is also regularly hit by meteorites. All of this makes lunar mining more difficult. In addition to the difficulty of mining, transportation is also difficult. Now it's just blocking. Not many countries on the moon can do that. Not to mention opening up a regional mining route. Statistically, geographic transportation costs are currently as high as $50,000 to $90,000 per kilogram. Something you can lift with one hand. From the Earth to the moon is the price of heaven. While lunar mining may seem difficult, layer upon layer, however, there are already intelligent collaborative building and mining programs in place. Mining doesn't require humans to go up there themselves. Instead, we have some versatile robots performing multi-party synergies for mining operations. For the exploitation of sailors, various methods such as temperature control and infusion mining have also been proposed. Can be effectively utilized, preparing people to live on the moon in the future. US, Japan take 2 steps ahead in space mining. Can China catch up? The treasures of space are the drifting asteroids. These asteroids are divided into 3 main categories. Carbon-containing is type C. Silicon, acid, alkali and metal mixtures are S-type. M-type for those containing iron and nickel. Either type of asteroid has resources that are scarce on Earth. High mining value. According to expert estimates, an asteroid is worth at least $10 billion to start with. Mining of asteroids is a 3-step process. Initial step. Launch a probe to the asteroid to detect the presence of precious metals. The resources are, just go to the next step. The second step is exploration. Development of an exploration program based on the location, composition, etc. of asteroids. Samples were collected and returned for study to determine the value of mining. Go to step 3 again. That is, official mining. The countries that have successfully completed the first 2 are currently the United States and Japan. 2020 US OSIRIS-REx probe successfully returns from Bennu asteroid sampling. Japan's probe Hayabusa 2, launched in 2020, brought back 5.4 samples from the asteroid called Ryugu. Amino acids were identified from the samples. On asteroid mining, my country is not moving that fast. Launch of Tianwen 2 is planned around 2025. Detection and sampling of a near-Earth asteroid. We have the capability to conduct preparatory sampling. Mars exploration. It's not hard to detect and sample from an asteroid. The reason why we are behind the United States and Japan. It's a steady march forward. Reduce space transportation costs first, in order to better conducting space mining. To bring the ore back to Earth in a safe manner for efficient use. Although the detection and survey phase is also a technological contest. But it's only when you actually step on a mine that you're really good. It didn't go all the way. All leads can be overtaken. Okay, that's it for today's video.